Hi, boys and girls. Happy April. It's Miss Messina here from Team Cortland.
Hi, Mrs. Cabrera from Team Stony Brook.
Hi, it's Diane Schwartz from Team Cortland.
Hi, Mrs. Viola from Team Geneseo.
Hi, Mrs. Levin from Team Purchase.
And hi, Miss Hidalgo from Team Geneseo.
So, boys and girls, we are all so proud of each and every one of you. Your effort, the time you are spending is really showing, and we're proud of each and every one of you. So, boys and girls, we are very, very aware how Schoology has been crashing over the past week or two. And some of you have been bumped out of Schoology as you're trying to work. We know that these things are going to happen as the weeks go on, with so many people overcrowding the system at the same time. Just keep in mind, you do not need to stress when that does happen. You can go on either at a later time to try to complete assignments. And if it gets too late and you still can't get on, remember, we're very flexible that we can receive assignments the day later. So we don't want you to stress out because we're all in the same boat. So we just wanted to mention that you don't need to email us and be stressed in any way. So boys and girls, let's start with a really fun activity that we're going to be doing today all together. We're going to start today by reviewing some key concepts from past lessons. First, what do you know about molecules in a liquid?
I know that molecules in a liquid are attracted to each other, but are able to move past each other. Remember how we tried to break up the water droplets last week? How does heating or cooling affect the speed of the molecules and the distance between them?
I know that heating speeds up the molecules and their motion and spreads them apart. Cooling slows down the motion of molecules and moves them closer together. Do you remember how I put food coloring in the hot water and the cold water and mixed it, and it wound up mixing so much faster in the hot water? That showed the molecules in the hot water were moving, and moving much, much faster than molecules in the cold water. Do you think atoms in a solid are attracted to each other?
I think that the atoms in a solid are also attracted to each other. This must be why they have a definite shape. Do you think heating or cooling a solid might affect the motion of the atoms?
Yeah, I think that the heating may make a difference, just like in the liquid. So let's think about that. In the liquid, the molecules moved faster. Do we think that's going to happen in a solid? I think it probably will, because I think the molecules in the solid, just like in the liquid, will spread out and move faster. And when it cools, the molecules will come back together and move slower.
For today, you will follow along with us, so pay close attention. Let's begin by observing an animation to determine how molecules in a solid move. Notice how the particles are attracted to each other. See how they are vibrating, but not moving past each other. Okay, notice how the particles are attracted to each other. See how the solid particles are vibrating, but not moving past each other. See how the solid keeps its shape.
Let's look at another animation that will compare solids and liquids. Notice how in a solid, the atoms are so attracted to each other that they vibrate and don't move past each other. Notice how in a liquid, the atoms are attracted to each other, but they move past each other.
Let's look at a demonstration involving a metal ball and ring. This will show us how heat causes atoms to spread further apart. This will also show us how cooling causes the atoms to get a little closer together.
So here we have the metal ball and ring. And you can see how the metal ball passes through the ring really easily. Now it's going to be heated. What do you think is going to happen? Why do you think that the ball won't fit through the ring? Now they're going to cool it down. What do you think is going to happen once it's cool? Why is it that the ball can fit through the ring now?
So we just observed the ball and ring demonstration. What was happening to the molecules of the metal ball when it was heated? What was happening to the molecules in the metal ring when it was at room temperature, when it was cooled down?
We can see in this animation that the molecules vibrate faster. Spread out slightly, but stay in their place when the solid is heated. The molecules vibrate more slowly at room temperature, and they also move closer together.
Now that we know how solids react to being cooled or heated, why is it important to have flexible connections on something like a bridge? Let's think about the bridge in the summer and think about the bridge in the winter.
Mhm. So go ahead and answer all the questions in the PDF. Submit the entire PDF, which is due Tuesday.